Hello students. So today also I am doing class for class 12. The topic is the same topic that we were doing in the last online class. That is, the topic is inverse circular function. So this is the continuation part. Okay. So same page number, that is page number 99. Exercise 4, each question carries 5 marks. Right. So let's do question number 12. So in this case also you have to prove that. Right? So you have to prove that cos inverse within bracket cos x plus cos y divided by 1 plus cos x cos y is equal to 2 tan inverse within bracket tan x by 2 tan y by 2. So you can prove LHS is equal to RHS. So let us prove it from the right hand side, because you know the formula of 2 tan inverse x, isn't it, in terms of cos inverse. So this 2 tan inverse x should be converted in terms of cos inverse. So what is the formula? So 2 tan inverse x is equal to cos inverse within bracket 1 minus x square upon 1 plus x square. So this is the formula that you can use here. Okay. So which is equal to, what is 2 tan inverse? What is x in this case? It is tan x by 2 into tan y by 2. Let us use that formula. Okay. So cos inverse, so within bracket 1 minus, what is x square in this case? It is tan square x by 2 tan square y by 2 whole divided by 1 plus x square. What is x square out here? It is tan square x by 2 then tan square y by 2. Is that clear? So now what will you do in the next step? So what will you do in the next step now? Now you can change this tan square into sin by cos, because you have to prove in terms of cos x plus cos y upon 1 minus cos x cos y. Okay. So let us convert this tan square into sin square by cos square. So is equal to cos inverse within bracket 1 minus, it is sin square x by 2 upon cos square x by 2 into sin square y upon cos square y by 2, this whole divided by 1 plus sin square x by 2 upon, this is cos square x by 2 into sin square y by 2 upon, this is your cos square y by 2. Is that clear? So now what will you do in the next step? You can take the LCM. You can take the LCM in both the numerator as well as in the denominator. What's the LCM? It is cos square x by 2 is the LCM. And this LCM in both the numerator and the denominator will be cancelled, so that you can simplify it. Okay. So what's the LCM in the numerator? It is cos square x by 2 into cos square y by 2. Right. So let us simplify the numerator. Cos square x by 2 into cos square y by 2, right? So cos square x by 2 into cos square y by 2 into 1. So it is cos square x by 2 cos square y by 2 minus sin square x by 2 into sin square y by 2. So this whole divided by, in the denominator also the LCM is cos square x by 2 cos square y by 2, right? So cos square x by 2 into cos square y by 2 into 1 is, it is cos square x by 2 cos square y by 2, then what? Plus sign. Then plus, what do we get? Sin square x by 2 into sin square y by 2. And this LCM will be cancelled from both the numerator as well as in the denominator. Is it clear to all of you? So now what will you do in the next step? So in the next step, what will you do? So we can use a formula out there. Okay. So what is the formula that you can use here? This is cos square x by 2 and this is cos square y by 2. And this is sin square x by 2, sin square y by 2. So in this case, we can use the formula of 2 cos square theta by 2 is equal to 1 plus cos theta. That is one of the formulae. And the other formula is 2 sine square theta by 2, which is equal to, it is 1 minus cos theta. Is that clear? So that means we should write here 2 and 2. 2 cos square x by 2, 2 cos square y by 2. That is 4. You should multiply it by 4 also. Second term should also be multiplied by 4. That is 2, 2. So if you multiply the numerator by 4, you should multiply the denominator also by 4. That means 2 into 2. Okay? So we are multiplying both numerator and the denominator by 4. That is 2 into 2. Okay? So is equal to cos inverse. Now within second bracket, so it is 2 cos square x by 2 into 2 cos square y by 2. Right? Then minus, this is 2 sine square x by 2, 2 sine square y by 2. Is that clear now? So we have multiplied both the terms in the numerator by 4. That is 2 into 2. So now in the denominator also, this is 2 cos square x by 2 into 2 cos square y by 2. Right? Then plus sign. Plus what do we get here? 2 sine square x by 2 into 2 sine square y by 2. So here second bracket is closed. So why are we multiplying each and every term by 2? Because we can use the formula of 2 cos square theta by 2 and 2 sine square theta by 2. We can use this formula, right? So now, so let us use the formula now. Now right hand side will be cos inverse within second bracket. What is 1? Now what is 2 cos square x by 2? That is 1 plus cos x, right? 1 plus cos x. Similarly, what is 2 cos square y by 2? The formula is 1 plus cos y. Okay? Then minus sign. Now what's about 2 sine square theta by 2? 1 minus cos theta. But here it is 1 minus cos x. Similarly, what is 2 sine square y? Similarly, what is 2 sine square y by 2? It is 1 minus cos y. It is 1 minus cos y whole divided by, in the denominator, what is 2 cos square x by 2? 1 plus cos x. What is 2 cos square y by 2? 1 plus cos y, right? Plus, then what's about 2 sine square x by 2? 1 minus cos x. And what is that? 2 sine square y by 2. It is 2 sine square y by 2, isn't it? So it is 1 minus cos y. Is that clear now? So this is the simplification. That is, we are using the formula of 2 cos square theta by 2 is equal to 1 plus cos theta, and 2 sine square theta by 2 is equal to 1 minus cos theta. Okay? So is equal to cos inverse. Now within second bracket, let us simplify it. Let us multiply these two factors. So it is 1 1 0, 1 plus 1 into cos y plus cos x into 1 cos x plus cos x into cos y. That is cos x cos y. Is that clear? Next, you have to multiply these two factors. You have to multiply these two factors and also multiply by minus here, minus there. So it is minus 1, minus 2, minus plus cos y, minus 2 minus plus cos x, right? Minus 2 minus plus, plus 2 minus, minus, that is cos x cos y. Clear? So whole divided by. So in the denominator also you can multiply them. Okay? So 1 1 is 1 plus 1 into cos y plus cos x into 1 cos x plus this is cos x cos y. This is cos x cos y plus next. This is 1 1 is 1 minus cos y, right? Minus cos x minus 2 minus plus. This is your cos x cos y. Second bracket is closed. Is it clear now? So now you can cancel the similar terms, but they should be of opposite sign, isn't it? That is, this plus 1 minus 1 gets cancels, cos x cos y plus minus gets cancels, here cos y gets cancelled, and here cos x gets cancels. So is equal to cos inverse, now within second bracket. Now cos x plus cos x, 2 cos x plus cos y plus cos y, 2 cos y whole divided by, in the denominator 1 plus 1 is 2 plus cos x cos y plus cos x cos y. What is it? It is 2 cos x cos y. Your second bracket is closed. Is it clear now? So now in the numerator what is common? 2. In the denominator also 2 is common. Both of them will be cancelled because they are in the numerator and in the denominator. So you can cancel that 2. So which is equal to cos inverse within bracket. What can you write? It is cos x plus cos y, this whole divided by, in the denominator what do we write? 1 plus cos x cos y. So which is equal to left hand side. So we have proved this RHS is equal to LHS. So I think you have understood it. So you can copy it. We'll do the next question now. So now let's do question number 13. Here also you have to prove that this LHS is equal to RHS. What is LHS here? Half cos inverse within bracket 5 cos x plus 3 whole divided by 5 plus 3 cos x is equal to, you have to prove that tan inverse within bracket half into tan x by 2. Okay. So here also let us prove it from right hand side, because you know this formula, isn't it? That is 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square. So this is the formula that you can use here also. Okay, but we need 2 in front of tan inverse. It should be 2 tan inverse x form. Here x is half tan x by 2, right? So we need half there, half into 2. We need 2 there actually. Actually we need 2 here in front of tan inverse. So you can write half into 2, isn't it? So is equal to, you can write half into 2 tan inverse within bracket half tan x by 2. So now you can easily prove this left hand side. Okay, so this is your 2 tan inverse x. Here x is half tan x by 2. So you can use that formula, cos inverse within bracket 1 minus x square upon 1 plus x square. Okay, so is equal to half cos inverse within bracket 1 minus, what is x whole square? Half tan x by 2 whole square, that is 1/4 tan square x by 2 divided by 1 plus, what is x whole square again? It is 1/4 tan square x by 2. Is that clear? So now let's simplify it. So let us convert this tan square in terms of sin square by cos square, because we have to prove here cos inverse within bracket 5 cos x plus 3 divided by 5 plus 3 cos x. Okay, so is equal to half cos inverse within bracket 1 minus 1/4 into, this is sin square x by 2 upon cos square x by 2 divided by, so what can you write? 1 plus 1/4 into, this is sin square x by 2 upon cos square x by 2, bracket closed. Okay, so we have used the formula for tan square x by 2, that is sin square x by 2 upon cos square x by 2. Okay, now you can get the LCM in both the numerator and the denominator. The LCM are same, so that LCM will be cancelled. Okay, so what do we get? Half cos inverse within bracket 4 cos square x by 2 into 1. What is it? 4 cos square x by 2 minus what? Sin square x by 2 minus sin square x by 2 whole divided by, in the denominator again, 4 cos square x by 2 into 1. It is 4 cos square x by 2 into 1 is 4 cos square x by 2 plus sin square x by 2 plus sin square x by 2. Okay. So now in this case also you can use the formula of 2 cos square x by 2 and 2 sin square x by 2. You should know it, isn't it? So in the previous problem also we use that formula, that is 2 cos square x by 2 is equal to 1 plus cos x, right? And the other one is 2 sin square x by 2 is equal to 1 minus cos x. That is 2 cos square x by 2 is equal to 1 plus cos x, and 2 sin square x by 2 is equal to 1 minus cos x. So we have to use this formula in this case. But we need 2 here also. It should be 2 sin square x by 2. If you multiply the second term by 2, you should multiply the first term by 2 also. If you multiply the numerator by 2, you should multiply the denominator by 2 also. That is, we have to multiply both numerator and the denominator by 2, right? So it's equal to half cos inverse within second bracket 4 into, this is your 2 cos square x by 2 minus 2 sin square x by 2, right? So we have multiplied the numerator by 2. Also multiply the denominator by 2 here. So 4 into, this is 2 cos square x by 2 plus 2 sin square x by 2. Here second bracket is closed. Is that clear? Now next, let us put the formula for 2 cos square x by 2 and 2 sin square x by 2. Okay? So it's equal to half cos inverse within second bracket 4 into, what is 2 cos square x by 2? It is 1 plus cos x minus, what is that? 2 sin square x by 2. What is the formula? Within bracket you write 1 minus cos x whole divided by, in the denominator also, 4 into, what is 2 cos square x by 2? It is 1 plus cos x plus, again what is 2 sin square x by 2? 1 minus cos x. So here second bracket is closed, right? So now let us simplify it. So now you can simplify it further, which is equal to half cos inverse, now within bracket. So you can multiply by 4 there. So it is 4 ones are 4 plus 4 cos x, and next minus 1 minus 2 minus plus cos x, right? So whole divided by, in the denominator 4 ones are 4 plus 4 cos x, next plus 1 minus cos x, bracket closed. Is that clear? Now next step, so it is half cos inverse within bracket 4 minus 1 is 3 plus, what is 4 cos x plus cos x? 5 cos x whole divided by 4 plus 1 is 5, and what is plus 4 cos x minus cos x? It is plus 3 cos x. So did you get the answer? That is half cos inverse 3 plus 5 cos x, same expression. This is 5 plus 3 cos x. So which is equal to right hand side. So we have, which is equal to, sorry, left hand side. That is where proof RHS is equal to LHS. Okay. So we'll do the next one. You can copy it. Now we will prove question number 14. Prove that tan inverse within bracket 1 minus x upon 1 plus x minus tan inverse within bracket 1 minus y upon 1 plus y is equal to tan inverse. Now within second bracket there is y minus x whole divided by, within square root there are two factors, 1 plus x square into 1 plus y square, right? So let us write down LHS, left hand side. So LHS is equal to tan inverse 1 minus x upon 1 plus x minus tan inverse within bracket 1 minus y upon 1 plus y. So in this case, you cannot use the formula of tan inverse x minus tan inverse y here. If you take x as this fraction and y as this fraction, it will be complicated for you to simplify the expression using the formula of tan inverse x minus tan inverse y. Okay, so let us use the formula here. This is the formula what? Tan inverse x minus y upon 1 plus xy. Here x is 1 and y is x, right? So that means you can use here tan inverse 1 minus x upon 1 plus 1 into x. This is the formula now. Minus tan inverse, this is also, you can simplify it. Similarly, here x is 1, right? So 1 minus, what is y here? It is y. Divided by 1 plus xy. That is 1 into y, right? So let us use the formula now. This is tan inverse x minus y upon 1 plus xy. This is also tan inverse x minus y upon 1 plus xy, right? So what is the formula you can use here? It is tan inverse 1 minus tan inverse x, right? But in this case, minus within bracket. Let us write it within bracket because there is minus sign here. So what is the formula here? It is tan inverse 1 minus tan inverse y. Is that clear? So now you can open this bracket. Tan inverse 1 minus tan inverse x minus tan inverse 1 minus or minus plus. This is your tan inverse y. Right? So we can cancel here. Tan inverse 1 gets cancels, which is equal to tan inverse y minus tan inverse x. So we got this expression, that is tan inverse y minus tan inverse x. So this is the simplified form, isn't it? This is the simplified form of this left hand side. Now you can easily use the formula of tan inverse x minus tan inverse y. Instead of x there is y, and instead of y there is x. Okay, here x is y and y is x. So use the formula now again. What is the formula? Tan inverse y minus x, that is x minus y, divided by 1 plus xy. But here what is 1 plus xy? 1 plus yx. Is that understood now? So now what will you do in the next step? You have to convert this tan inverse in terms of sine inverse, right? So let us convert it into sine inverse. Let us assume, let tan inverse y minus x upon 1 plus yx is equal to theta. Okay, so let us assume tan inverse within bracket y minus x upon 1 plus yx is equal to theta, right? So now tan inverse take to the right hand side, or y minus x divided by 1 plus yx is equal to tan theta. That is, we have got the value for tan theta, which is equal to y minus x upon 1 plus yx. Okay, so in order to convert this tan inverse in terms of sine inverse, let us find out the value for sine theta first. Let us use PBH formula. Okay, but you know that tan theta is equal to P by B. But what is tan theta? It is P upon B. So we can equate P by B with y minus x upon 1 plus yx. Is that clear? So now you can equate here. Let us write P is equal to y minus x. P is equal to y minus x, and what is B in this case? It is 1 plus yx, right? So now what do we need here? We need the value for h. You know Pythagoras theorem. What is Pythagoras theorem? H square is equal to b square plus p square. So h is equal to root over, it will be p square plus b square, right? So or h is equal to root over, what is p whole square? It is y minus x whole square plus what is b whole square? it is 1 plus yx whole square. Let us simplify it. Or h is equal to root under, now this is your a minus b whole square. You know the formula. What is the formula? What is a whole square? Y square. What is minus 2ab? Minus 2yx. What is plus b square? It is x square plus. Similarly, this is your a plus b whole square. What is a whole square? 1 whole square, that is 1. Plus twice into 1 into yx, that is twice yx. Plus, what is b square? It is y square, x square. Is that clear? So here you can cancel. This 2yx and 2yx gets cancels. Or h is equal to, now within square root. What are the remaining terms here? 1 plus x square plus y square plus y square x square. Let us factorize it. So 1 plus x square, let us write 1 plus x square plus, then write on y square plus y square x square. So you can take common here. You can take common from the first two terms and then take common from the next two terms. Right? So now in the next step, or h is equal to root over, what is common from the first two terms? Only one is common there. No common. Actually there is one is common there. 1 within bracket, 1 plus x square plus, from the next two terms what is common? Y square within bracket, it is 1 plus x square, right? Or h is equal to within square root, what is common again? 1 plus x square taken common, so within bracket what do we have? 1 plus y square. So 1 plus x square is common here, and the remaining terms are also closed within, are also written within bracket. Okay, so this is the value for h. Now in order to express the left hand side in terms of sine inverse, you have to get the value for sine theta. Okay, so sine theta, what is the formula? Some people have sine theta is equal to p by h, or sine theta is equal to, what is p in this case? What was the value for p? P is y minus x, isn't it? So y minus x divided by, what is the value for h? We have just determined it. That is, what is the value for h? It is root over 1 plus x square into 1 plus y square. Is that clear now? So therefore, theta is equal to, let us take this sine to the right hand side. That means it becomes sine inverse. So within second bracket, y minus x divided by root over, it is 1 plus x square into 1 plus y square. So this is the value for theta. So this is your square, right? Understood now? So actually, what was the left hand side? We had simplified left hand side, that is LHS. This LHS was simplified and we got this expression, isn't it? That is tan inverse y minus x upon 1 plus yx, right? And this was assumed as theta. This was assumed as theta. And what was the value for theta? This sine inverse. Okay. So sine inverse within second bracket, write down this expression. That is y minus x divided by what? Within square root. It is 1 plus x square into 1 plus y square. So this is the final answer, which is equal to right hand side. So we have proved it. Okay. So we have proved the required result. So you can copy it. Let's do the next question. So now we will do question number 16. So if sine of within first bracket pi cos theta is equal to cos within bracket pi sine theta, then so that theta is equal to plus minus half sine inverse 3 upon 4. You have to prove the value for theta from this given. Okay. So let us write down this given. sine of pi cos theta is equal to cos pi sin theta. Okay. So now in order to cancel this sine, you have to convert this cos into sine. You can use the formula, that is cos theta is equal to sine pi by 2 minus theta, isn't it? That is cos theta is equal to sine within bracket 90 degree minus theta, or in terms of radian it is pi by 2. Okay. So or this is your sine within bracket pi cos theta is equal to, we are converting this cos into sine. So what is the formula? Sine of within bracket pi by 2 and theta is pi sin theta minus pi sin theta. Is that clear now? So from both the sides, what can you cancel? From both the sides you can cancel this sine. That means you don't have to write sine in the next step. Or this is pi cos theta is equal to pi by 2 minus pi sin theta. Is that clear? So now let us take this minus pi sin theta to the left hand side. So what does it become? It is pi cos theta plus pi sin theta is equal to pi by 2. So what is common out here? It is pi within bracket cos theta plus sin theta is equal to pi by 2. Is that clear? So here you can cancel this, pi gets cancelled, that is one time. Pi ones are pi, pi ones are pi. That means pi is cancelled and we get 1 out here. Okay? So or it is cos theta plus sin theta is equal to, this is 1 upon 2. Is that clear to all of you? So now what will you do in the next step? You have to get the value for theta, and theta is equal to plus minus half sine inverse 3 by 4. So let us square both the sides. Okay? So let's see what happens if we square both the sides. Right on, squaring both the sides. Squaring both the sides. So what do we get? Squaring both the sides, what do we get? Therefore, cos theta plus sin theta whole square is equal to, it is half whole square, isn't it? You have to square both the sides. It is 1/4, right? Half whole square is 1/4. So now, what is the left hand side now? A plus b whole square. A square plus b square plus twice ab. Let us write here cos square theta plus sin square theta plus 2 sin theta cos theta is equal to 1/4. Is that clear? Next, what is this? Cos square theta plus sin square theta, that is 1. Plus next, what is 2 sin theta cos theta? It is what? Sin 2 theta is equal to 1/4. Is it clear? Next, what is the value for sin 2 theta is equal to? Sin 2 theta is equal to, sin 2 theta is equal to 1/4 minus 1, or sin 2 theta is equal to, this will be minus 3 by 4. It will be minus 3 upon 4. Is it clear? So next, what will you do? Let us take that minus sign on the left hand side. So it is minus sin 2 theta is equal to, this is 3 by 4, right? Or you may write here sine of minus 2 theta. Is that clear now? Minus sine 2 theta means you can write sine of minus 2 theta. Sine of negative angle is always negative sine angle, right? So we can write here sine of minus 2 theta is equal to 3 by 4, okay? Or minus 2 theta is equal to, this is your sine inverse 3 by 4, and let us take this minus 2 to the right hand side. So theta is equal to, this is minus half sine inverse 3 by 4. So one of the relation is proved. That is, we have proved that in this case theta is equal to minus half sine inverse 3 upon 4. Is it understood now? That is, we have proved theta is equal to, one of the relation is proved, that is minus half sine inverse 3 by 4. Now what should we prove? Plus sign also there. plus sign is also there, isn't it? So let us prove now theta is equal to plus half sine inverse 3 by 4 from this given. Okay. So how can you prove it now? Again, given is sine of pi cos theta is equal to cos within bracket pi sine theta. Okay. So this is the given part. Now left hand side remains same, that is sine pi cos theta. Now how can you write down this right hand side? The formula for which expression is cos theta. Again, if you write sine pi by 2 plus theta. What is sine pi by 2 plus theta? Now pi by 2 plus theta lies in the second quadrant. Pi by 2 plus theta lies in the second quadrant, and in the second quadrant sine is always positive. Okay. Then what should you write here? Plus pi, this is your sine theta. This is pi sine theta. Is that clear? That is sine 90 plus pi sine theta. That is pi by 2 plus theta lies in the second quadrant, and in the second quadrant sine is always positive. You will get positive. So positive sign usually we don't write, and it is 19 to 1, that is odd multiple, so sine changes to cos. And theta, what is theta there? It is pi sine theta. Is that clear to all of you? So we got this relation now. So now from both the sides, what can we cancel? From both the sides you can cancel sine. So don't write sine in the next step. That is pi cos theta is equal to pi by 2 plus pi sine theta. Is it clear? So now let us simplify it. You can simplify in the same way that we have done in the previous one. Okay. So pi cos theta, let us take this pi sine theta to the left hand side. It is pi sine theta is equal to, this is your pi by 2. So here pi is common within bracket, cos theta minus sine theta is equal to pi by 2. From both the sides you can cancel this common term, that is pi, cancel it, or cos theta minus sine theta is equal to pi by, it is 1 by 2, right? That is cos theta minus sine theta is equal to half. Here pi gets cancelled from both the sides. So let us square both the sides again. So write down squaring both the sides. Squaring both the sides. So squaring both the sides, what do we get? Therefore cos theta minus sine theta whole square is equal to, right inside it is also half whole square, that is 1/4, right? Or now this is your a minus b whole square. What is a minus b whole square? A square, that is cos square theta, plus what is b whole square? It is sine square theta. Then minus twice ab. What is twice ab? It is 2 cos theta sine theta, which is equal to 1/4, right? So now you know that what is cos square theta plus sine square theta, that is 1, minus, you know this formula from multiple angles. What is 2 sine theta cos theta? That is sine 2 theta is equal to 1/4, right? Or next, minus sine 2 theta is equal to 1/4 minus 1, or minus sine 2 theta is equal to 1/4 minus 1 is minus 3/4, isn't it? 4 ones are 4, that is minus 4 plus 1 is minus 3 divided by 4. So from both the sides you can cancel this minus sine. So now what is the value for 2 theta? Therefore 2 theta is equal to, sine goes to the right hand side, becomes sine inverse. That is sine inverse 3/4. Or what is the value for theta now? Theta is equal to half. This is sine inverse 3/4. So in the previous steps we proved that theta is equal to minus half sine inverse 3/4. So just now we proved that theta is equal to half sine inverse 3/4. So combining these two, what can you write? So hence what can you write? Hence theta is equal to, combine these two, you will write plus minus sine inverse 3/4. So it is proved. So we have proved the required result. Okay, so I think you have understood the simplification, so you can practice it at home. So we'll do the next question, right? Now we will do question number 18. Okay, so if 2 cos 4 theta plus 9 cos 2 theta minus 7 is equal to 0, it is given. You have to prove that, you have to prove the value for theta is equal to half cos inverse 3/4. So let us write down this given part. 2 cos 4 theta plus 9 cos 2 theta minus 7 is equal to 0, right? So now since this is in terms of cos 2 theta, let us write this cos 4 theta in terms of cos 2 theta, okay? Or 2 cos 2 into 2 theta, right? Plus 9 cos 2 theta minus 7 is equal to 0. Now you should write down the formula for cos 2a. So can you tell me what is the formula for cos 2a from multiple angles in terms of cos? You have to express this cos 4 theta in terms of cos 2 theta. So you have to express cos 2a in terms of cos. What is the formula? It is 2 cos square a minus 1. Here, cos 2a is equal to 2 cos square a minus 1. That is the formula from multiple angles in trigonometry, right? So, or what is a here? It is 2 theta. Use that formula, right? So 2 into within bracket. What is the formula? 2 cos square. What is a out here? It is 2 theta. Then what do we write? Minus 1, right? Plus 9 cos 2 theta minus 7 is equal to 0. Remain same. So let's simplify it. Now 2 to the 4 cos square 2 theta minus 2 ones are 2 plus 9 cos 2 theta minus 7 is equal to 0, or 4 cos square 2 theta plus 9 cos 2 theta, then what is minus 2 minus 7? Minus 9, which is equal to 0. Is it clear now? So now can you factorize it? So 4 into 9 is 36. If you multiply the two numbers, you should get 9 fours are 36. Okay? And since there is minus sign here, after subtracting that two numbers, you should get 9. Because there is minus sign here. So after subtracting that two numbers, you should get 9. So what are those two numbers? 12 threes are 36. And 12 minus 3 is this 9, right? So let us write 4 cos square 2 theta plus 12 minus 3 into cos 2 theta minus 9, which is equal to 0. Is that clear? So now you can easily factorize that expression, that is 4 cos square 2 theta plus within bracket 12 minus 3 bracket close into cos 2 theta minus 9 is equal to 0 is there. Okay? So, or 4 cos square 2 theta, right? Plus 12 cos 2 theta. 12 cos 2 theta. Next, plus and minus 3 cos 2 theta. Minus 3 cos 2 theta. Then minus 9. Which is equal to 0. Okay? So now take common from the first two terms. What is common here? 4 cos 2 theta is common. Within bracket, what do we get? It is cos 2 theta plus 3, right? Then next two terms, what is common there? Minus 3 within bracket cos 2 theta plus 3, which is equal to 0. So next, what is common here? It is cos 2 theta plus 3 is taken common here. So remaining terms you should write it within bracket, that is cos 2 theta minus 3, which is equal to 0. So we have factorized it. Okay. So you can write either first factor is equal to 0 or second factor is equal to 0. So either cos 2 theta plus 3 is equal to 0, or you can write 4 cos 2 theta minus 3 is equal to 0, right? That is either cos 2 theta plus 3 is equal to 0 or 4 cos 2 theta minus 3 is equal to 0, right? So now, from the first equation, that is cos 2 theta plus 3 is equal to 0. Okay. Now from the first equation, that is cos 2 theta plus 3 is equal to 0 is there. What is the value for cos 2 theta? Cos 2 theta is equal to minus 3. But is cos 2 theta is equal to minus 3 valid? You know that cos of an angle always lies within minus 1 and plus 1. We know that cos 2 theta always lies within minus 1 to plus 1. यो cos 2 theta को value चाहिँ जहिले पनि minus 1 र 1 को भित्र मात्रै हुन्छ. Cos 2 theta should not be greater than 1. Cos 2 theta should not be less than minus 1. Okay? But here cos 2 theta is minus 3. So minus 3 is less than minus 1. So the value of cos 2 theta cannot be minus 3. Understood? So this is the reason that cos 2 theta not equal to minus 3. Because the value of cos 2 theta should lie between minus 1 and plus 1. So but cos 2 theta not equal to minus 3. Okay? But there is another equation. What is another equation? 4 cos 2 theta minus 3 is equal to 0. Or 4 cos 2 theta is equal to 3. Or what is the value for cos 2 theta is equal to, this is your 3 by 4. But 3 by 4 is the valid value, isn't it? This 3 by 4 is more than minus 1, but it is less than 1. 3 by 4 means it is just like your 0.75, that is, which is 0.75 like that, which is less than 1. That is 3 by 4 lies within minus 1 and plus 1. So this is the valid value for cos 2 theta. So you can prove it now. Or what is 2 theta is equal to? Cos inverse 3 by 4. That means cos is taken to the right hand side. So it becomes cos inverse, right? Or what is the value of theta? It is half cos inverse 3 by 4. Got it? So 2 is taken to the right hand side. So it goes to the denominator. So theta is equal to half cos inverse 3 by 4. So it is proved. Okay. So we have done question number 18. So let's do the next question now. Now we will do question number 17. In this case, you have to prove that a cos theta plus b sin theta is equal to within square root a square plus b square, then cos of within bracket theta minus tan inverse b by a again is equal to root over a square plus b square, then sin of within bracket theta plus tan inverse a by b. So in this case, there are two problems here. That is, you have to prove first is equal to second, and you have to prove first is equal to third. So let us prove first is equal to second first. Okay. So now LHS is equal to a cos theta plus b sin theta. Now you have to express this a cos theta plus b sin theta in terms of cos of a minus b, isn't it? And before cos there is also root under a square plus b square is also there. So you have to convert this into compound angle form, that is cos of a minus b. So in this case you have to assume a and b. So in order to convert this into cos of a minus b form, let us assume let a is equal to r cos alpha. if we put A is equal to R cos alpha, this will be R cos alpha cos theta. And what should be the value for B? B is equal to R sin alpha, right? So let us mark it as number 1. This A is equal to R cos alpha as 1, and this B is equal to R sin alpha as 2. So in this case, R and alpha are the unknown quantity. So you should get the values for R and alpha in terms of A and B. First of all, you get the value for R eliminating alpha in terms of A and B. Okay, that means you have to square both the sides of 1 and 2. So write down squaring both the sides, of 1 and 2. So what do we get? So A square is equal to R square cos square alpha, and below it square both the sides of number 2. What is it? B square is equal to R square. This is sin square alpha, right? So let us add them. Or A square plus B square is equal to, here R square is common. If we add these two, R square will be common. So within bracket we have cos square alpha plus sin square alpha, right? So what is cos square alpha plus sin square alpha? It is always 1. So or A square plus B square is equal to R square. Or what is the value for R? It is root over A square plus B square. That means we got the value for R is equal to root under A square plus B square. Okay. So we have got the value for R in terms of A and B eliminating alpha. Okay. Now you have to get the value for alpha. Now we have to get the value for alpha from 1 and 2 eliminating R. That means we can divide it. If we divide 2 by 1, R can be cancelled, since you have to get in terms of tan inverse. So divide 2 by 1. So write down dividing 2 by 1. So dividing 2 by 1, right? So we are dividing 2 by 1. So write down left hand side of number 2, that is B, divided by, write down left hand side of number 1. What is it? A, which is equal to, this is 2 divided by 1, that is B by A, is equal to, write down right hand side of number 2 in the numerator, that is R sin alpha divided by, in the denominator you should write down the right hand side of number 1, that is R cos alpha. This is your R cos alpha. Is that clear? So here you can cancel this R, cancel them, or it is B by A is equal to, what is sin alpha by cos alpha? That is tan alpha. Now let us get the value for alpha. What is alpha is equal to? It is tan inverse B upon A. Is that clear to all of you? So I think you have understood it, right? So now let us prove this first is equal to second now. So write down LHS. What is LHS here? Again write down left hand side. What was LHS? Write down, it is A cos theta plus B sin theta. A cos theta plus B sin theta, which is equal to, now what will you write for A? We had assumed A is equal to R cos alpha. Write down R cos alpha. Then cos theta plus, similarly what is B? B is R sin alpha. R sin alpha, then you write sin theta. Is it clear? So next one, which is equal to, what is common here? Here the common is R. So within bracket you first write theta cos alpha, then plus, what should you write? Sin theta sin alpha. Now you know this formula. This is cos A cos B plus sin A sin B. And this is the formula from trigonometry, compound angle. What is cos A cos B plus sin A sin B? It is cos of A minus B. So which is equal to R cos of, what is A minus B here? It is theta minus alpha. So let us put the value for both R and alpha. Okay. Now let us put both the values of R and alpha. What is R? It is root over a square plus b square into cos of within bracket theta minus, what is alpha in this case? It is tan inverse. It is tan inverse b upon a. So is it proved? So which is equal to right hand side. So it is proved. Okay. Similarly, can you prove this first is equal to third? So this is your homework. Okay. I'll give you the hint. Similarly, as in the previous problem, you can prove this first is equal to third. Okay. Now I'm giving the hints. So this is your homework. That is you have to prove first is equal to third, right? So left hand side is equal to a sin theta plus b cos theta. Right? Now in this case, it is a cos theta, right? This is a cos theta plus it is b sin theta. So in this case, you have to prove root over a square plus b square into sine of within bracket theta plus tan inverse a by b. That is, sine of a plus b should be there. Okay? So in this case, let us put, let a is equal to what? A is equal to k and this one. You can put let a is equal to r sine alpha. Let us mark it number 1, and b is equal to r cos alpha. This is number 2. In the first case, we put a is equal to r cos alpha and b is equal to r sin alpha. But in this case, we are putting a is equal to r sin alpha and b is equal to r cos alpha. Because if you put a is equal to r sin alpha, a is equal to r sin alpha cos theta, plus b is equal to r cos alpha is plus b r cos alpha sin theta. If you take common, you will get sin a cos b plus cos a sin b, which is equal to sin of a plus b. Now, you can use the similar method in this case also, as we have done in the first part. So, I think you can do it. Now you can prove first is equal to this third. So we have achieved a is equal to r sin alpha and b is equal to r cos alpha. So from here, number 1 and number 2, squaring and adding, you can get the value for r in terms of a and b, eliminating alpha. Get it? And also get the value for alpha. Also get the value for alpha, eliminating r. You should get alpha is equal to tan inverse a by b. That means you have to divide. Dividing 1 by 2, you will get the value for alpha. Okay? So as in the previous problems, that is as in the previous steps, or as in the previous part, you can prove this left hand side is equal to this third expression. So this is your homework. Now I think you can do first is equal to third also. So first you revise first is equal to second. You revise how is it proved. First is equal to second. Then you can easily prove first is equal to third. Okay. Now I'll give you some homework, right? So now this question number 15 is your homework. Okay. So this is very important question. So question number 15 is, if cos inverse x plus cos inverse y is equal to theta, then prove that x square minus 2xy cos theta plus y square is equal to sin square theta. Okay. So write down given, use the formula on the left hand side, cos inverse x plus cos inverse y. You know this formula. Okay. That is cos inverse x plus cos inverse y को formula लेख्नु. अनि त्यहाँदेखि फर्मुला यसरी cos इन्भर्स लाई राइट साइडमा लानु, बुझ्यौ? त्यहाँदेखि केलाई तिमीले स्क्वायर रुटलाई एक्लै पार्नु एउटा साइडमा, अनि एउटा साइडमा चाहिँ स्क्वायर रुट नभएको टर्म्सहरु राखेर स्क्वायरिङ गर्नु, so that you can remove the square root. And in that case also, after simplification, you will get this LHS is equal to RHS. Okay? So this much is for today. So we have finished almost all the problems from the book. Revise all the problems that we have done so far. Okay. So in the next class, we will do questions from HS question paper. Okay. So this much is for today. Okay. Thank you.